Now this illustration deals with grounding electrode conductor for multiple separately derived systems in accordance with NEC 250.30A6A as in Apple. Now notice here we have a common grounding electrode conductor. We've already stated that it does not have to be larger than 3/0 without design requires it to be larger. And where it might require it is for sensitive electronic equipment and so forth under certain conditions to help equalize as close as possible impedance differences between equipment. But notice this, the transformers there are connecting a grounding electrode conductor from each unit, and when I say unit, separately derived system transformer, and using that common grounding electrode conductor to connect the secondary side of those transformers to the grounding electrode system. In this case, is structural steel in accordance with 250.52A2. But notice the metal frame of the building or the grounding electrode system must be designed and installed and inspected according to 250.30A6, A1, A2, and 250.68C1 in C2. The common grounding electrode conductor, as I just previously stated, if it's a conductor, wire type conductor, 3/0 as large it would have to be in accordance with 250.30. A6, A1 is an apple, as well as 250.30A6, A2 is an apple. And then the figure loops of additional information can be seen and reviewed in our figure 16-47. And then we show the ungrounded phase conductors from the secondary side of the transformers is 4/0, and based upon the 4/0, 250.66 requires a number 2 from the secondary side of the transformer connected to the 3/0 common grounding electrode conductor. So this figure 16-49 is dealing with the grounding electrode conductor for multiple separately derived systems when you would have a 3/0 is shown, maximum size, and the tap conductors from the individual separately derived system sized based upon the secondary conductor supplying the equipment. And that's what this illustration 16-49 is illustrating.